So, fade with a potentiometer, 5.1. When we start going through this, first of all, we need to find the Arduino. We need to find a breadboard. So I'll drop both of these in here. We're going to wire up the positive side on both sides, and we'll make that be red. And we're going to connect that to the 5-volt leg on the Arduino. Make that red as well. Now we're going to connect up a ground wire. Make that a black wire. And we need to connect a ground wire up from one side to the next over here as well. Again, we'll change that to be black. So we've just set that up now so that we have 5 volts running through both our positives and ground running through both of our negatives. So we'll be ready to start wiring up the circuit. So the first thing we need is an LED, I suppose, right? Doesn't really matter, okay? And that can be red, that's fine. We're gonna find, we're gonna find a resistor here because the LED requires a resistor to keep it from blowing out. Okay, and then we're gonna resistor, my LEDs keep doing this. Let's see here. LED. There we go. Okay, as far as this side here, because we're going to be using analog right later on to fade this thing, we're going to connect this up to a PWM pin. I guess in this case 11. Change this to be yellow wire since it's going to an input. Then for the potentiometer itself, remember your potentiometer has 3 legs on it. You have your wiper leg in the middle. You have your 2 terminals on either side. Okay, so one side of your terminal needs to go to ground. One side of your terminal needs to go to 5 volts. So we'll change that to be red. We'll change this to be black. And then we need one wire to go to an analog input. So we're going to bring that around. And I'll connect this up to analog 0. Okay, and again, I want to change this color, make that blue for right now. Maybe something different. All right, that's good there. So at this point, we should be able to have like a potentiometer set up, right? And we can actually go in and do some quick coding here. I'm going to come into text and I'm going to create a constant integer for my potentiometer pin, which is going to be set to A0. I'm going to set a constant integer for my LED pin, which is going to be set to 11. So we'll call this LED pin. That's my output. I'm going to have an input. I'm going to initialize my pot pin as an input. And I want to turn on serial begin and start that up. So the first thing here that we can do is we can create a new integer inside this, and we're going to first get our potentiometer state, and that's going to be set to an analog read because we're going to read an analog device of the pot pin. Okay, and pot state is going to be that value. So if I like serial print and I say pot state, and just for the sake of it for right now, we'll set up like a short delay. And we'll start our simulation. So our simulation is running right now. If we go to our serial monitor, we can see that this is equal to 0. And as we turn our potentiometer runs up to be 1023. So with that information, we can set up, we can stop our simulation. And we can come in now, we can use a map. Okay, so remember, we're going to create this like new integer. I'm going to call this maybe like LED value. This is going to be what we'd like write our LED with. It's going to be set to a map, and a map has 5 arguments again. First argument is the input, which in this case is pot state. That's going to range from 0 on our low end, which is our second argument, to 1023 on our high end, which is our third argument. And then we need to scale it down to what we want. The low end is going to be 0, which is going to be the low end of the LED value, which is right here. And then the high end is 255, which is the upper value of an analog write. So if we now say serial.print ln, and instead of it being pot state, we can say that it's an LED value. I'm just going to get rid of this here for the moment. Okay, so I'm just commenting that out. When I start my simulation now, instead of printing pot state from 0 to 1023, we're actually going to print LED value, which is our map. So our map is 0 at the bottom end and 255 at the top end, which is the same values that we can use for analog write. So when we come through here and we start working on our analog write information, we can say, so this is going to be like turning our LED on. We can say analog write our LED pin, our LED states. Okay, this value is going to range, well, first of all, it's going to send a PWM signal to pin 11, which is LED pin. It's going to send it that LED state, which is the value that's going from 0 to 255. So when we start our simulation, LED state, I'm sorry, LED value. Excuse me. Okay, so as we start coming through here, now our LED is getting brighter the higher this is, okay? And it might be easier to see that if we change our resistor value. Right now it's like a 1 kilo ohm, which is probably higher than it needs to be. You can probably set this to be like a 220 ohm resistor. That'll be fine. And again, now when we come through here to the bottom, it's off. And as we turn it higher, it gets brighter. And then we turn it off again. Okay, so that's how we can go through and set up 5.1 and go through the code here. Now, the last thing that we'll need to do is add comments. We'll need to add our name. You can then copy your code, paste it into Classroom like we did when we were in school, and then you can email me and let me know that you're done with this code, and I'll take a look at it. Make sure you add your comments. Okay, good luck, guys. Bye-bye.